live again. Well, hello, and welcome again today for the stream. Today I'm gonna do another crypto one, which is fun. Last time we built a ERC20 token, meaning we built our own cryptocurrency, and then we haven't deployed it anywhere, but we kind of figured out how to do it. I talked a little bit why to do it, and then we tried to interact with it a little bit. But one thing I mentioned and didn't go too much into is that there are currently quite a high fees on the Ethereum network, which is what we're like coding against most of the time, because Ethereum came with the idea, or like one of the founders, I guess, came up with this language Solidity that we're using to write the contract. And then the obvious thing is to just kind of upload the smart contract to Ethereum smart blockchain, and that works. That's fine, but the problem is that Ethereum is kind of popular right now, and there is a fixed amount of transaction it can do per some interval of time. And then how that works is that when you kind of sign up to send your transaction in, you specify how much you're willing to pay in fees for the transaction. Like, you most likely don't do that manually. There's this algorithm that looks into previous gas fees for previous transactions, and it does a recommended transaction for you, and you kind of just approve it. But you still put some amount of transaction fee. And then the miners who compete to mine the next block, they basically choose the most paying transactions. So that means we have like a limited supply of spaces for transactions, and we have ever increasing number of transactions to put into that supply. So that means the fees will just keep going higher and higher. Like, obviously people are aware of this, including Ethereum devs, and there are a bunch of let's say optimizations that they are thinking about. Like, one good resource, let me switch here. One good research for that is here, Ethereum org scaling. I guess if you go down here, there are a bunch of different solutions or ways you can implement sort of optimization in this way, so you don't end up with those high fees on each transaction. But the problem is they are all kind of more involved. I will try to look into them some more and maybe do a video about those. But they're kind of more complex. So usually you would do big part of the transaction, of the amount of transaction outside of the main Ethereum blockchain, and then you kind of push the proof that you've done the transaction inside the main layer 1 blockchain, Ethereum in this case. That works, but needs more work. One thing they don't talk about here that you can do is that you can use a different blockchain, obviously. Why you can use a different blockchain is because, well, in tech industry, we're always saying that we're like standing on the shoulders of the giants, and it's very true. Whenever you build something, you're like 90% of that solutions you provided is just some libraries and stuff you picked up from somebody else. And the same is true for blockchain, cryptocurrency land, even more so actually. So many of the new cryptocurrencies, they just kind of take what's worked for Ethereum and then build something on top of it, or just rebrand it or something like that. So one example of such, so what's important part for us that they took over is the EVM, or Ethereum Virtual Machine. An Ethereum Virtual Machine is basically the thing that runs that bytecode in the end. So we write the Solidity code, like in this example we wrote this beaver coin example, and then when we compile this with Solidity compiler, it will create a bytecode file, which is like a binary encoded thing, and then it's going to be sent into this Ethereum virtual machine, and Ethereum virtual machine knows how to interpret that binary file and knows how to run that smart contract of yours. But the thing is that many blockchains are using the exact same Ethereum virtual machine, or are just compliant with the interface of this binary code. So they implement the same operations that you do in EVM. So what that means is that we can just take this Solidity code, compile it, and push it to other blockchains that use the same EVM, right? So that's exactly what we're gonna do. What other options do you have? There are like several. You would Google one. There's Ethereum Classic, which is very close to Ethereum, and it's very decentralized as well. But the one I'm gonna talk about today is Binance Smart Chain. And why Binance Smart Chain is because the fees are super low there, and then time to execute them is super, it's fast. Because that's another thing, that it's not only about the amount of fees, it's also about how long it takes for your for a transaction to be actually mined within the block, so that it's confirmed. Now, there is a problem with there is a trade-off when you're doing this sort of thing. There's a trade-off, of course. So when we're going to Binance Smart Chain, there's a trade-off because Binance Smart Chain isn't decentralized that much, to be honest. So in Ethereum right now we're doing proof of work. So that means that anybody's grandma computer can be used to mine Ethereum. There's a very little chance that that computer would be able to, but in theory you could do that. And then each computer that is trying to mine is just competing with all the other miners and trying to guess some cryptographic puzzle. And if you get it first, you won. You get to mine the next block. And if you do that, then you get all the rewards that the miners get, like Ethereum in this case. So that's proof of work. And then and that's what's the big topic about in Bitcoin as well, is that it consumes a lot of energy because you have all these computers competing, and then difficulty of the puzzle needs to increase with how many computers are actually competing, so it's in balance all the time. So that means that these machines run a lot of puzzles, and the puzzles are not specifically useful, they're just needs to be solved so you can mine stuff. Ethereum is moving towards the Casper protocol, which is going to be proof of stake protocol. In that case, there's no more trying to figure out a puzzle, but basically the chance that you will be chosen to mine the next block is based on the amount of ether you staked. So very simplistically, we could say that that how much of big stake you have in Ethereum, how much Ethereum you own within the network, that's how likely you will be chosen to mine it. It's a little bit more complex than that, but that's the gist of it. But that means you no longer do these hard cryptographic puzzles, and you no longer do this lot of computation. So that's a proof of stake solution. And then I was talking about good question. What is proof of history? I don't know, actually. I haven't looked into Solana yet. So this whole my streaming thing is about me learning how to do this kind of things. But it's a very good point. I'll try to look into Solana. I think they're doing the Rust. So here we're doing Solidity programming language. I think their smart contract is Rust, if I'm not mistaken, which I'm just trying to get into. But yeah, good question. Um, so I was talking about Binance Smart Chain. They use this consensus mechanism that is called proof of stake authority or something like that. Basically, they have 21 chosen players that mine the blocks. But those are, you can imagine it as companies affiliated with the Binance centralized exchange. Right? So that's a very centralized solution. But as we said, the benefit is obviously low fees and fast transaction time. And it's still public blockchain, so you can still look up all the information you want from the blockchain. Cool. So, that was the boring part, the intro, I hope. And then next I'm gonna do the basic deployments. So I'm gonna do deployment to test network, the regular Ethereum test network, Ringcabby. And then I'm gonna try to deploy to Binance Smart Chain test network, just to see how that works. Alright, so how would we do that? So in truffle config here, last time we created this development and we connected to Ganache, which was local, blockchain runs on your laptop. It's all good. What we're gonna do today is do uncomment one of more of these blocks. Yep. Oh. And set it up so that it works. So Ringcabby is one of the test networks. There are many more, or two more, and you basically, to interact with any of the networks, you need to have a client that is connected, like a node inside this network that you send your signed transactions to. When we had the local solution, we would have the whole blockchain and all the clients, which was the only client, the one running on your laptop. So we connected localhost, on your laptop with some specific port to that client. Now, if you want to connect to Ringcabby, you have two options. I think on one of the previous videos we just ran the Geth client locally on your laptop, and you could still connect to that Geth client that was connected in that network, and that worked. But it's a little bit more involved because you need to set up the Geth client and everything. But what you can do here as well is connect to some existing node in the network that accepts external requests. And there's this service called Infura, and you can set up your own project there. You can use their APIs basically for the client, which is something we're gonna do today. So before we do that, we need to have an account, because whenever you do deployments, you do it as an account on the network, and then you pay a little bit of the fee to deploy your smart contract there. So how would you do that? So first, let's get Metamouse Plugin. How do I need to download it? Boop. So Metamouse Plugin is a plugin into Chrome that lets you. It's a cryptocurrency wallet. So it lets you create these kind of private public keys pairs and then use it to sign transactions and so on. So many websites would invoke this plugin to actually sign the transactions whenever you need to do something. Well, I don't know what it's checking. Oh yeah, we're downloading it here. So that's first part of the puzzle. While it's downloading, it's here, cool. Oops. Alright. So let's create a new wallet here. This is not your private key, but this is how this works. Is your MetaMask encrypts your private keys, and then it's using yeah, sure. And then it's using your password to kind of decrypt the private keys to access them. So it's like one private key to rule them all. Yeah, what's happening here? Did I not do that correctly? Or do I actually need to read what it's saying? Okay. Remind me later. I don't want to do that. Cool. So now we have one Ethereum account. So if we look like Etherscan, we basically see the same thing. Like we could copy this account, go here, and see there's like nothing in it. There's no transactions because it was just created. When you create an account, it doesn't like need to register it anywhere. It's just one-time thing. Like you create it on your machine ideally, or in the best case, and it just works. Now you can add networks. That's kind of bad. I thought there's gonna be... Oh, maybe here. Cool. Yes, this is what we wanted. Cool. So then we can switch to Rinkaby, this network, which is also, we have no ether there. So to get ether, you would go to Rinkaby faucet. And how this works is that, okay, it's not good. Okay, this is fine, maybe. Let's try something. Yeah, I have some proxies issues here in this place. I mean, it's co-working space, and sometimes this doesn't work. Yeah, okay. Let me see if I can figure out a better way to do this. No. Okay, so plan B. I have another client I can use where I already have Ethereum. So let's do that. Let me just clean that up. And should be pretty good. Cool. So here I already have this one. This account that already has some Ethereum on test network, so we can use that one instead. Let's do that. And then I need to be careful not to expose my keys then. It's just a test network, so it doesn't really matter. And I'm not using that account for anything else, but it's still... so I'm gonna get rid of this guy. Actually, maybe I can import it here. Let's do that. So I can... Account details? Here. Import account. Base your property. Yes, I'm gonna do that off screen. Just a sec. Boom, boom, boom. Sorry about that. I usually am very badly prepared, so this is what you get to expect. Cool. Right, so now I have this account here as well in this browser. I don't know what... Okay, so let's try to deploy from this account. Yes. So, what do we need here? We're using this HD wallet provider, which is another dependency we're gonna use. Basically you're gonna give it your private keys, and it's gonna sign the transactions when it's communicating with the client. To get it, we first need to install it. Yeah, this is the dependency we need. So to install it, you would do npm install. D here is dev dependency. I'm gonna explain what it does in the second when it finishes. Or maybe I can show you already. So in your package.json, you have dependencies which are built for a production build and are packaged in your production release as well, whatever the software is. It's not just Solidity, it's anything JavaScript related really, or anything using npm. And then, yeah, and dev dependencies are just built normally when you don't build production build, so that's in your development environment. And because we're just going to be using it from here, from your local computer, you don't need to package that. I guess that's just not that important, to be honest. So, okay, so we're going to uncomment this line, which is, importing this HD wallet from the dependency we just downloaded. Now, the default thing here is that you use the mnemoing phrase, which is a bunch of words that wallets generate, which is definitely a good choice. But it's sometimes you don't have that because you created the account differently, and then that whatever wallet you created it doesn't provide that. So something that works all the time is using your private key, because the mnemoing is used to generate the private keys for several accounts, and then the private keys are used to generate a public key. So if you skip the mnemoing, provide private keys directly, it still works because you gave it all the information it needs. I guess good practice is not to commit your private keys to Git repo, which is why I prepared this secrets example file. So we're just gonna copy it here and call it secrets.js, and then secrets.js is in git ignore, so it doesn't get committed. So now we can paste your private key here, and then in Fiora the endpoint itself. So first, let's get the Infura key. So to do that, you just go to Infura, I guess. Yes. Then you log in with my credentials. So I'm going to do this again. Perfect. So now you have your projects, you can set up projects. If you go to settings and you go to Ringkaby here, this is the endpoint you want. You can just copy it. Obviously I'm not using this project for anything, so that's why it's fine to expose it. You can put it here, and then I'm gonna put my private key here, which I'm gonna do next. So I'm gonna do this again, and I'm gonna grab that private key. Sorry, this is again, I guess, quite boring. but I think it's kind of nice to show you the whole way to set it up. Looks good. And then I'm obviously not gonna show the private key, so let's do this. Hopefully. Alright, so next up we gonna import this stuff that we just set it up, right? So we can do const here, boom, rules require, and then it's called secrets, and then from there we can fetch the infure endpoint and the private keys. Oh, by the way, it's array, so it's multiple keys, although I just put one key in there. You can put more, and then those, you will see later, those are the accounts you get access to. And then here, in the Ringkaby, we can change setup of this provider. I think they have a private keys, where you just put the private keys. And then they have URL, provider URL, where you can put that infure endpoint. And then we should be pretty good to go. So we can test that by running truffle, console, and then network that you're interested in. So Ringkaby. So you're putting in this keyword, Ringkaby. Let's see. Now it failed, which is fine. It's saying the network ID specified is free, but we got number 4. And that's because this block was designed for Robston, but we're using Ringkaby, so you just change that to 4. And that's just a security measure, that you're connected to the right thing that you're expecting to connect. So this is good, I think. Cool, now we can see that we connected, so we can do Web3 stuff. So we can do Web3, Ethereum, get balance, and then we can paste accounts 0. And we get the balance, which is this, which should be hopefully the same as this, 1876. So that's all good. Like, this is in ways, so this is the lowest denominator of Ethereum, but it's fine, right? And then one thing I just skipped over, there's this accounts variable that holds the public keys of our accounts, which are generated from the private keys that we just passed through here. So that's all good. I think you do Ctrl+C to exit, and then we can do truffle, deploy, and a network Ringkaby. This is still gonna take a little bit time. Network up to date. Okay, yeah, because I've done that before. When you say reset, you mean ignore whatever migration was run before, and then deploy them again. So what it complained before was that you've already deployed these contracts. So what are you doing? Because when you use the truffle project here, you get this migration project, smart contract automatically, and everyone keeps track of what migrations were already ran. So it's kind of smart to not let you deploy stuff twice or more. But if you do reset, it just ignores it and starts from 0. Deploys new smart contracts. One thing while we're waiting, here you can say how many confirmations it should wait between deployments. Why is that important is that when you send your transaction, some miners will pick them up, put them in their block, and say this is the new head of the network. But somebody else on some other part of the planet did another block with different transaction in it and said, well, this is the head of the network, right? And then they both broadcast it to all the peers in the network, and they kind of say, oh, this is the guys on the right side, my right side, say, oh, this is the new, head from this guy, and they will say, this is the new head from that guy, and then it will propagate until, some nodes already have that head from the previous guy, so they have one more block than this person has, and then always the longest chain wins. And then here you basically waiting for confirmation from these different nodes that multiple nodes already said, oh, this is a valid chain. So in this network, which you can just wait for two confirmation, because the risk there is that you get the first confirmation, but that somebody else already populated the second their version of the smart chain further, and it will just invalidate the one that you got from the first confirmation. Sorry, it's a bit confusing. But anyway, this finished. So if we look at, let's look at this. So this is we're deploying the Bitcoin, and this is the address that we got here. And then if we look at, so this is Etherscan. Sorry, I didn't mention that, but here you can switch to different network. So you can switch to Rinkaby and search for this. And this is the contract being deployed. Right? There's just one transaction interacting with it, which is the creation, and this is the same address that we used to create it before. Okay, so the next step, what do you do with this? So you can interact with this contract the same way we've done in the development environment. You just connect to it. With console, we're connecting to this client. In this case, it runs in Infura, and we can read the blockchain and we can send transactions there. So we can say, yeah, let's do this. So we can fetch the instance of the contract that we just deployed. So Bitcoin add, and then boom. This is the address that we got from here, right? And the same one we just checked in Etherscan. Now we have a contract here, and then we can say mint, 100 coins. In the previous video we talked more about the ERC20 token, what the mint does, but it basically creates the 100 tokens to the sender of this transaction, and it's only allowed for the creator of the transaction. And if you don't specify sender, it assumes the first account from the accounts array, and this is the creator, so it just happens to work. But now we can do also balance of, and then accounts, and we can see this account has 100 tokens. So that's cool. That kind of works. That's awesome. But so far I haven't shown really anything new. But we've deployed to test network, and then if you would like to deploy to a production network, it's very easy, right? You would just use a different endpoint towards the production. You would change the network ID to the real, I guess 1 in Ethereum Smart Chain, and then you would have to use, account that actually has real Ether in it. So that's nice. But then we talked about doing Binance Smart Chain. So let's try to do the same thing for Binance Smart Chain. So Binance Smart Chain test. Again, we're just doing test network, so that we're not using real what's called BNB, I think, their tokens. Yes. First, let's connect to their Binance Smart Chain. I guess. No, or let's do this. I hope this is the right place. Yes, so they tell you how to set it up basically. And then there is a testnet and BCC. So in this case, we said that they have this 21 nodes in the network that do the mining. So in this case, you don't need any service that would act as a client that you would send a request towards. You just send it directly to the Binance, or I mean, the Binance has built-in service that you can use to interact with the clients. So this would be the endpoint to use. So if we go back here, instead of this, we can still use the same private keys, public keys, but obviously that public key doesn't have any BNBs in it. And we can actually verify that by, it actually has BNBs already, because now I realize, because it's the same one I've used before. But that doesn't matter, I guess. But then what you can do is configure a Metamask to kind of understand that other network as well. You can do add network here. And we can say Binance Smart Chain test. And this is the URL, which is the same thing I put in here. Chain ID, that I don't know, but I guess it should be here, 97. Yeah, there we all good. There's one more thing, which is Binance Smart Chain Etherscan, like alternative to Etherscan. Yeah, it's this thing. And then I guess here you can switch to testnet. Yep. So this is optional, but if you put it here, it kind of works as well. Okay, yeah. It should be correct. Oh, this might be just proxy issue again. GUI service, huh? Ooh, this is not good. If this doesn't work, that's gonna be bad. Okay, well, let's try here, but I guess it's not gonna work here either. Yeah, no, okay, it's underscore. Yeah, well, this is not good. Well, this worked at home, but I guess the network here is different. That sucks. Well, let's try the production. Like, we can't do deployments because I don't have any PNPs. Maybe it's the port that it doesn't like. I don't know. So let's try that. What was the 2019? It's 56. And I guess this would be this. I'm just guessing. Maybe it works. Alright, well, this kind of works. But this is unfortunate because we can't do the deployment, I think. It will be very similar, I guess. Let's just take this For instance, let's at least get some errors while we're doing this. So let's do real BSC, and then put the production endpoint. I guess it doesn't like the port for some reason. Yup, this one. Cool. And if we try to connect to BSC, it should complain about the network again. There was 56, I think. But let's see what the error says. Yeah, 56. Perfect, so that works. So that's exactly what you would do, I guess, when you're not in a co-working space that blocks different ports. But yeah, so you would do deploy to real network. My account has 0 balance, so it's just gonna fail, right? But yeah, that's how you would do it. Right. Insufficient funds. So that's exactly what you would do, and then you could still do the console to actually interact with it the same way we've done with Rinkaby. So yeah, so that was a little bit anticlimactic ending, but that's I guess I've shown everything, all the steps. It just didn't work. So if there are any questions, I will be happy to answer them. Otherwise, I'm just gonna stop it here. As always, thank you for bearing with me through this painful, boring stuff. It's kind of fun to learn it, so cool. Have a wonderful day, and bye.